Hello, Andika. How are you today?
Hello, I am feeling great. Thank you for asking. I am very excited to be here and to have the opportunity to interview for the RF planning engineer position at Ericsson.
Excellent. I am Nabil Fajri, senior planning engineer here at Edison. We focus a lot on optimizing mobile network, especially as we transition to 5 generation to start. Tell me a bit about your background and why you're interested in RF planning.
Here, I am a recent graduate in telecommunication engineering from State Polytechnic Negeri Padang. Throughout my studies, I developed a strong interest in wireless communications, particularly in and planning mobile networks. I find RF planning fascinating because it combines theoretical knowledge with real-world challenges, and I am excited to apply my skills to help shape the future of mobile networks, especially in 5th generation. Additionally, I have a strong background in antenna design, which I believe is a critical aspect of RF planning, especially for optimizing coverage and capacity in complex environments.
That's great to hear. Why Harrison? What interests you about working with us?
Ericsson has a long history of innovation and leadership in the telecom industry, especially with the development of 5th generation networks. I admire the company's commitment to driving the evolution of mobile networks globally. I believe my skills and enthusiasm for networks optimization align perfectly with Ericsson focus on cutting-edge technologies. And I am eager to the team. Also, my experience with antenna design and my academic contributions, including publisher articles on wireless communication and antenna design, have helped me develop a holistic understanding of RF engineering, which I am excited to bring to your team.
Sound like you done your RS. Harrison is currently a leader in the industry, and we are proud of our contribution to 5th generation. So let's dive deeper into year education. What specifically during your studies, Made, are you interested in RF planning?
During my time at Polytechnic Negeri Padang, I took specialist course in wireless communication, mobile network design, and RF propagation. I was particularly interested in learning about how radio waves propagate in different environments and how that affects capacity and overall network's performance. Additionally, I have experience designs antenna for various applications, which I believe plays a crucial role in ensuring network efficiency. I have published a couple of articles on antenna design that focus on optimized antenna performance in both urban and rural environments. One project in particular focused on improving LTE coverage in a suburban area, and it sparked my interest in RF planning because it allowed me to apply theoretical concepts to real world scenarios.
That's a relevant background. How did these courses prepare you for a career in RF planning?
My coursework provided me with a solid foundation in understanding networks component, signal propagation, and the tools used in RF planning, such as Atoll and Thames. I also gained hands-on experience with data analysis and simulation, which are essential skills for this role. Additionally, I learned about the latest trends in network technologies, including the shift from 4th generation to 5th generations, which I think is incredibly exciting for the future of RF planning. My experience with antenna design has also equipped me with a practical understanding how to optimize network coverage and performance, which is an important aspect of RF planning.
Excellent. It sounds like you have a strong technical foundation. Can you uh, me track a project that you worked on during your studies? For example, the one you mentioned regarding Kabupaten Malala.
Currently, as part of my learning project, I was involved in planning the addition of a new site in Kabupaten Malala. This was based on drive test data that highlight coverage gaps in the area. The first step was to analyze the data to identify areas with weak signal strength and high interference. We used tools like TEMS for data collection and ATOL for propagation modeling to simulate different site configuration. In addition to this, I applied my knowledge of antenna design to propose antenna types and configuration they would best address to coverage issues.
Can you describe the process of identifying the site location and optimizing it?
Sure. After analyzing the drive test data, we identified a few potential locations for the new site. We considered factors such as terrain, build, building height, and existing infrastructure. And for the optimization, we run several simulations to evaluate the performance of different site configuration, including antenna tilts and power setting. Additionally, I propose specific antenna types and configuration that could maximize signal coverage and reduce interference. The project also involved designing a custom antenna solution for the site to ensure that it would operate efficiently in the particular environment.
Sounds like a very detailed process. What challenge did you face?
One of the main challenges was dealing with interference from nearby existing site. We had to make sure that the new site would not create additional interference or cause network performance issues. Another challenge was balancing the need for optimal coverage with cost efficiency, as deploying new sites can be expensive. Additionally, designing antennas for complex environments, especially in urban areas, presented unique challenges in terms of minimizing signal loss and optimizing the antenna's radiation pattern.
How did you ensure the new site will interact smoothly with the exciting network?
We performed extensive simulation to model the potential impact of the new site on the surrounding network. by adjusting parameters such as antenna orientation, tilt, and power levels. You are able to minimize interface and improve overall network coverage. We also coordinate with the operations team to the NEO site was seamlessly integrated into the network architecture. My background in antenna design helped me ensure that the site's antenna were optimized for maximum coverage and minimal interference with other sites.
It is clear that uh, you gained some solid hands-on experience. Now let's talk about the tools you have worked with. The tools are you comfortable with in RF planning?
I have experience using a tool for network design and optimization. In the Malala project, I use it to simulate different site configuration and predict coverage and interference. I have also worked with them for conducting drive tests and collecting file data. I am familiar with path loss for propagation modeling and have a basic understanding of IB wave for indoor planning. Additionally, I am proficient in MATLAB for data analysis and simulation, I, which I use in my final project for network optimization. My knowledge of antenna software like GST Microwave Studios has also been useful in designing and simulating antenna for specific network requirement.
That's great. Are you familiar with any new technologies like 5G or AI for RF planning?
Yes, I have been studying five generation technologies, including the use of small cells and massive MIMO. I have also learned about how artificial intelligence or AI and machine learning are being integrated into RF planning, especially for automating tasks like network optimization and fault detection. I am particularly excited about how these technologies can improve network efficiently and performance, and I am eager to apply them in real-world scenarios. Additionally, in my research and article, I have explored how artificial intelligence can be used in antenna design to improve signal propagation and coverage.
Uh, AI and machine learning are definitely becoming key components of uh, RF planning. How do you see them impacting the future of the industry?
I believe AI will revolutionize the way we approach network optimization. By using machine learning algorithms to analyze network data, we can automate tasks like traffic forecasting, interference management, and even fault detection. This could drastically the time and resource needed to maintain and optimize networks. For fifth generation, this will be especially important due to the complexity of the network and the vast amount of data that needs to be processed in real time. Additionally, AI can help improve antenna design by predicting the optimal configuration for specific environment, whi- which will significantly enhance coverage and network performance.
Great insight. Moving on, can you share an example of a time when you worked in a team to solve a challenging problem?
Absolutely, during my final year projects, my team and I were tasked with optimizing LTE coverage is in a densely populated area. The main challenge was interference from exciting network, and high traffic demand. We collaborate closely to analyze data, emulate different solutions, and share insight. I was responsible for data analysis and modeling, and we worked together to propose a combination of small cell, macro cell deployment. The project taught me the importance of teamwork and communication in problem solving.
What role do you usually take in the project?
I typically take on the role of data analyst and optimizer. I enjoy working with data, running simulation, and identifying patterns that lead to actionable insight. However, I am also comfortable collaborating with others and combining to discussing on solution. I believe that the best results come from pulling knowledge and skill from everyone on the team.
That's a great attitude. Before we wrap up, do you have any question for me about the position or Edison?
Yes, I am curious about the project that Ericsson RF Planning team is currently working on. How do you see the role of a new engineer evolving as we move towards fifth generation and beyond?
Great question. We are currently focusing on optimization 5 generation deployment and exploring new solutions like alpha network optimization. As a new engineer, you all have the opportunity to contribute to this exciting project, learn from experienced team and members, and take on more responsibility as you gain expertise in RF planning and optimization.
That sounds like an amazing opportunity, and I'd love to be part of those innovative projects.
Thanks again for your time, Andika. It has been a pleasure speaking with you today. We will be in touch soon with the next step.
Thank you for your time as well. I look forward to hearing from you. Have a great day.